Today we will continue our algebra review. Today's lesson is on solving formulas. But before we get into it, how about a little riddle? Where were pencils born? Pennsylvania. Get it? Pennsylvania? Okay. Solving formulas is also known as solving literal equations. And usually, there's more than one variable in the equation. But we're trying to solve for y here, which means isolate y, or get y by itself. So I'm going to start by moving the 4x to the other side, so it now becomes negative 4x. And now I'm going to divide both sides by negative 2. Since I have two terms here, I'm going to do that separately. Negative over negative is positive. And now I have isolated y. There's no y on this side, so I'm done. Y equals 2x minus 3. Let's do one that has fractions in it. Go ahead and pause the video and give it a try for yourself. You want to isolate x. The first thing I'm going to do is clear the fractions. This is not the only way to do it. This is just my suggestion. Clear fractions first. So I'm going to multiply by the common denominator, which is 2. That's going to make this 2 cancel, and I have 2y equals n times x minus 1. At this point, you have a couple of choices. You can distribute the n, but I wouldn't, because my goal is to get x by itself. I would, well, let me show you both ways. Let's do that. Here's one way. You can start off by distributing the n. And now I want to get x by itself. So I'm going to add n to both sides. Stay focused. X is the goal. So I have 2y plus n. And now x is almost alone. All I have to do is divide both sides by n. You can separate it like so, would be my suggestion. And you have x by itself, 2y over n plus 1. X is by itself, and there's no x on this side. For whatever reason, I like to have my x on this side. I'm just saying. I like my x on the left. But it's fine the other way, as long as it's by itself. Now, another way of doing it, I'll say this is an alternate method of solving this problem. Once you get here, you can divide both sides by n, because remember, we're trying to get x by itself. And so now I have 2y over n equals x minus 1. And now I'm going to add 1 to both sides. And I get x equals 2y over n plus 1. So you notice that is the exact same answer. Another way we could have written this answer, when we were here, and let me change colors just so I don't confuse anyone. When we were right here, we could have written it all over n. So that's another way of doing it, and these are all equivalent. That's the same thing, okay? Let's look at the next problem. I want to solve for x. So again, that means isolate x. But I want you to notice we have x in two locations. So in order to get x by itself, we need to put them right next to each other on the same side of the equation and then factor the x out. And let me show you what I mean. I'm going to move this over here. So it's going to become negative. I just subtracted xy from both sides. And I'm going to move this over here. So positive 5 becomes negative 5. Now that I have both x's next to each other, I'm going to factor the x out. Again, I'm trying to get x by itself. So I've gone from having x in two places to x only in one place. Whatever stuck to my x, I'm going to divide both sides. So now I have x equals negative 5 over 4 minus y. And that's a good answer right there. However, you might be taking like a multiple choice test, so it may look different. It may look like this. If we were to take, and this is just a little sidebar, if we were to multiply top and bottom by -1 on the top and bottom, anything over itself is 1, so that doesn't change the value. But what would happen is I'd get positive 5 over -4 plus y, which is positive 5 over y minus 4. So this is this is equivalent to that. And I want you to realize that. So instead of putting the negative with the numerator, you could just factor that negative through the denominator, and it'd be the same thing. Okay?